Howdy, ladies and gentlemen. Welcome to part 8, reactions of aromatic compounds, re benzene. I just used benzene for all of them, and probably so did your buck. Alrighty then, let's get started. With benzene, you're going to want to start with benzene. From there, you can directly do a lot of stuff. I'm just going to work in columns and go through the little chart I made, one bit at a time. These are the basics. These are the benzene rings that aren't substituted yet, and also side chain reactions. Then part 2, we're going to talk a little bit about directing effects and what to do if you're trying to do some of this stuff to a benzene ring that already has some stuff on it. Great. Benzene, the first thing you can do is a Br2 and FeBr3. That just adds bromine. FeBr3 is a Lewis acid catalyst. From bromine, you can do lots of typical bromine stuff, like you can make it into a Grignard using magnesium, or you can react it with a Gilman reagent. Just sort of use that as the alkyl halide on the other end of an organometallic synthesis. Or you can do essentially the same thing, but instead of using a Gilman, use a Suzuki reagent and a PDL2 catalyst. Don't know why you do that instead of the Gilman. Maybe if you wanted something sensitive to other functional groups on the other side of your compound. But if you can do this instead, it's cheaper. Now, next thing, Cl2-FeCl3 looks a lot like your Br2-FeBr3. Thing you can do with that is sort of misplaced in this chart because it goes by a different mechanism. This goes through a benzene intermediate mechanism, but you can do NaNH2 and NH3 liquid to replace your chlorine with an NH2. Then another way to get NH2 on a ring, which is going to be pretty important because you can do a lot of things with that, is to just nitrate it with HNO3 and H2SO4. Then you can reduce it, and there are heaps and heaps and heaps of ways to reduce it. A really common one is your just basic reducing agent H2PDC. You can also use tin and hydrochloric acid, SnCl2 and hydrochloric acid, or Fe in this ethanoic acid. Then you get down here to your NH2. This is quite a special reaction. You do NaNO2 and hydrochloric acid at 0 degrees centigrade. Also written HONO or HNO3 because the hydrogen of hydrochloric acid protonates one of those oxygens. So that's just written straight out, and that's just written with the H in front of it. You may see it written either way on the thing. You get this. This is a diazonium compound. And you can react it with something that's already activated. And activating directs para, we'll talk about that in a second, to sort of link it up. And it's not a triple bond anymore, it's a double bond. Well, activators go ortho-para, but in this case it goes para because it's pretty sterically hindered. So para is going to be your major product. Other things you can do with this, if you react it with HBF4, you can replace those two nitrogens with a fluorine. CuCl2 will replace it with a chlorine. CuBr will replace it, or not CuCl2, CuCl. Chlorine. CuBr will replace it with a bromine. Ki, iodine. CuCN will replace it with the C triple bond N group, cyano. If you want to turn it into a phenol, a good, very specific way of doing that is Cu2O, CuNO32, and water. If you want to bring that back down to a benzene ring, you use H3PO2. And if you want to take this cyano group and turn it into CH3NH2, you use H2 and rainy nickel. Now we're going to go back up to our start. And this is a reaction that's commonly seen, sulfonation. Use sulfuric acid and heat. This is a special one. This is the friedl-crafts alkylation. I put a star by it because this example it doesn't happen, but in the first step, this catalyst rips off that chlorine, leaving a carbocation there. If this were any longer, if it were 3 carbons long, for example, you would have a 1' carbocation next to a 2' carbocation, which would rearrange, which you may or may not want depending on the circumstances. So in this case, I used one that did not rearrange. If you wanted a longer straight chain and you wanted to add it on here, you would go through a different pathway. You would start with this is the friedl-crafts acylation, because a carbonyl carbocation doesn't rearrange, so when you rip that off you're good regardless of how long that chain is. So this is sometimes written without the second water step. That's sort of a workup, and that's shown here. You get that it just tacks on that carbonyl group, and then you can reduce it back to your just alkane using one of 2 things. The Clemmensen reduction occurs in acidic conditions if you want that. That's ZnHG and HCl with heat. And then the Wolff-Kishner reduction, H2N and NH2 in basic conditions, OH minus and heat. If you want to add iodine to your ring, and I've skipped some stuff down here, I'm going to go back to it. It's sort of a hodgepodge. I'll get back to it. If you want to put iodine on, put I2 and H2O2 in acid. And this is called the gatterman-koch reaction. If you want to just put a single carbon with a double bond to an O and a hydrogen on it to make an aldehyde, you can't really use friedl-crafts directly because it's not stable. So what you do is you generate what you need in C2 so it doesn't break down. To do that, you use carbon monoxide and hydrochloric acid under pressure. And that again is the gatterman-koch. Back down to this mess right here that we haven't covered yet that starts with the friedl-crafts alkylation. If you want to take that, cleave off everything but the first carbon to make a carboxylic acid, you can use strong oxidizing agents like KMNO4 and NaOH if you want basic conditions, or CrO3 and H2SO4 if you want acidic conditions. If you want to pop a bromine on allylically, use NBS ROR, which we talked about in our last video. Well, it's benzylically in this case, but it also works for allylic. If you want to take that and eliminate it, you use sodium tert-butoxide or potassium tert-butoxide. If instead you want to take that guy and replace the Br with an OH, you use KOH. That's gonna be, I should have drawn the arrow differently, but that's gonna be in equilibrium with the brominated product. You're not gonna get a yield out of that you really want. If you want to take that and oxidize it back, you use the same oxidizing agents you used up here. Those are just strong oxidizing agents. They'll take you to a carboxylic acid, no sweat. If you want to oxidize it a little more mildly, use something like MnO2 and heat, or pyridinium chlorochromate might work. If you want to eliminate the alcohol, you can use a dehydration reaction, H2SO4 and heat. Once you get the alkene that's been dehydrated or eliminated already or dehydrated, you can put bromine on it, anti-Markovnikov, HBr ROR, which we talked about in our radical section, or going way back to Orgo 1, you can do BH3THF and OH minus H2O2 and H2O to put OH on anti-Markovnikov. That's hydroboration, oxidation.